Hello friends, in our previous lecture we have started chapter number 4, measures of dispersion. In that I have said there are total 6 exercises, and in that 4.1, 4.3 and 4.6 will not be included for this year in the syllabus, whereas remaining exercise 4.2, 4.4 and 4.5 will be included. So in our yesterday's lecture we have completed exercise 4.2, that was regarding quartile deviation. Now we shall go for the next measure, that is standard deviation. Okay, now what do you mean by this standard deviation? Let's see. So it's given on page number 140. We have seen the definition of mean deviation. Okay, that is ignored. On the basis of absolute values of deviations of observations from the mean. Since the algebraic signs of deviations are ignored, mean deviation is less used in advanced studies. So I already said the government has deducted, that's okay. This limitation of mean deviation is overcome by important measure of dispersion, that is standard deviation. So you should remember the most important measures of dispersion is standard deviation. Instead of taking the absolute value of deviation, each observation from the mean, the square is taken. If the sum of squares of this deviation is divided by total number of observations, we get an important measure that is known as variance. It is denoted by s square. Positive square root is standard deviation. It is denoted by s. So standard deviation is denoted by s, and if we remove the square root and keep a square, that is variance. Well-known statistician Carl Pearson defined standard deviation as, underline that thing, definition of standard deviation. Standard deviation is the positive square root of mean of squares of deviation taken from the mean. Positive square of mean of deviations taken from the mean. After mean, standard deviation is another very useful measure which gives information about the values of observation of the population. Note that standard deviation is an absolute value of dispersion. If standard deviation is divided by the mean of data, we get its relative measure of dispersion. It is called coefficient of standard deviation, that is s by x bar. That coefficient of standard deviation is s upon x bar, its relative measure. Okay, now its formulas. So let's write. See here, shortcut method is given, but as I have not taken shortcut method in mean, same way I will not take shortcut method here, because that shortcut method is actually long cut method for us. Okay, yeah. So everyone will write in your notebooks. Standard deviation it is an important measure of dispersion it is denoted by small letter s and its square is variance, that is s square. Okay. Formulas. Now for each type of data we have formulas, that is for ungrouped or raw data, discrete and continuous data, and two formulas. Now you will think, why two formulas? I will explain. Okay. When x bar is integer, when x bar is non-integer. First is for raw or ungrouped data. Heading will be same for both. So I will cancel till here. Okay. Standard deviation S is in square root sigma x minus x bar square upon n. And if it is non-integer, then s is equals to in square root sigma x square by n minus x bar square. Okay. Second is for discrete data. Standard deviation S is in square root sigma f multiply x minus x bar square upon n. Power supply as well. Here S is equals to in square root sigma fx square by n minus x bar square. And last, number 3. For continuous data, S same is formula is same. Sigma f x minus x bar square upon n. This I am just writing for a formality. Formula is same. Here also S is equals to in square root sigma fx square by n minus x bar square. Now you all may be thinking that I have given two formulas for each. So first you have to every time remember that when x bar is integer means without decimal points and x bar is not integer. So friends, one thing I have to tell that in this chapter only such formulas are there. Now this standard deviation is coming in 5th chapter also, then always these formulas are used, these are not used. So we will also do the same thing. For a sake of writing, we have written the formulas for a sake of writing or for a formality. But every time we will use this formula, whether x bar is integer or non-integer, this formula only we will use because this is easy to compute. In this we will take more time. Columns are more and here columns are less. Why? Because the reason I will say. See, this is raw or unproved data. So only observations will be given. So first column is x. Then you have to prepare a column of x minus x bar. Then you have to prepare a column after x minus x bar square. Directly you cannot prepare x minus x bar square. So here 3 columns, x minus x bar, then x minus x bar square. Comparing here which columns? X is given and take only x square and x bar is found directly. Okay, so here 2 columns, here 1 column. In the same way, here sigma f x minus x bar square by n. So first column will be x, second column will be frequency for discrete data. Then we need fx because in every we need x bar. So then x, f, fx, then a column x minus x bar, then x minus x bar square, then f into x minus x bar square. So there are x, f, fx, then x minus x bar square, and f into x minus x bar square. 6 columns. And compare with here. X and f will be given, so fx is there, and only draw a column of fx square. So x, f, fx, and fx square. Nothing else. So here 4 columns, here 6 columns. In the same way, here it will be 1 extra because class is given. So for comparing, we have to make class for fx values. We have to find the mid values, so 1 extra column. So comparing, this method has more columns and this method has less columns. So we will use this method only. So we will write it down. Formulas are given for understanding, comma, we will use only The second type of formulas whether x bar is a integer or non-integer. Formulas are given for understanding. We will use only second types, all this. This is the first type, this is second type. Second type of formulas whether x bar is integer or non-integer. So always we will use this thing only. We will not use this thing. We will use this thing. Okay? This is for our understanding. You should know the things. Okay. So this was absolute measure. Now relative measure. So I will write here absolute measure. All these are absolute measure. Now relative measure. Coefficient of standard deviation is equals to S by x bar, and I will write here relative measure. Friends, these are the formulas. This we will not use, only we will use this. And for relative or coefficient of standard deviation, S upon x bar means the answer divided by the mean which we have found. Now we are going for exercise 4.4. So remember only this line, okay? Because columns are less and some will be solved fast. And for next chapters also we will require only second type of formulas, not the first type, because it is taking so much time. On page number 149, exercise 4.4. The marks obtained by 9 students in a test of 100 marks in mathematics are given below: 64, 63, 72, 65, 68, 69, 66, 67, 69. Find the standard deviation of marks obtained by students. Power supply. Okay. So we have to find the standard deviation. Friends, we are not finding quartiles. So we are not required to arrange the data. Let the data be like that only, but we will draw column of x for that. After that we will draw x square column. So remember, in ungrouped or row data, we will require only one extra column. X is given, that first column. Second column we require only x square, nothing else. And in discrete data, x and f will be given, so fx and fx square. In continuous data, class and frequency will be given, so x, fx and fx square. Simple things. Understand by seeing the formula only. Yeah. Okay. So we are in exercise 4.4 and in that going for the first sum. Marks is the column of x and we require just x square. 64, 63, 72, 65, 68, 69, 66, 67, 69. Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why we are not arranging? Because we are just finding standard deviation. We are not doing anything else. Okay? Yes. First we will find the mean. For each type of data, first is required is mean only. Sigma x. Okay. Then x bar is equals to sigma x by 64, 63, 72, 65, 68, 69, 66, 67 and 69. Total is 603. 603 divided by 9. 67. So x bar is 67 notice. So the first step is to find the mean. Now directly x square. Okay, we are using all the second formulas only. So columns are less. Now how to take the square by using the calculator is very easy. You want to take the square of 64. So what you will do? 64 multiply and equals to. You will directly 4096. Then 63 into equals to 3969. See, we have calculators, so don't worry about the values. 72 into equal to 5184. 65 into equals to 4225. So what is the simple method? The value into an equal to, so it is square. 68 into equal to 4624. 69 square is 4761. 66 square is 4356. 67 square is 4489. 69 square is 4761. Let's take the total. 4096, 3969, 5184, 4225, 4624, 4761, 4356, 4489, 4761, 40,465. Have the habit of checking. We have the feature check and correct. So 4096, 3969, 5184, 4225, 4624, 4761, 4356, 4489 and 4761. Now standard deviation. First was mean, second is standard deviation. S is equals to, don't forget first the square root. If you are forgetting, then it will become variance. Sigma x square by n minus x bar square. So I am telling first find x bar only. So sigma x square is 40,465. N is not 603 here, n is 9 because number of values are 9. Minus x bar is 67 whole square. You use any method, answer will only come. 40,465 divided by 9. 4496.111, so 11 minus 67 square 4489. So 4496.11 minus 4489, square root of 7.11. So how to take the square root of 7.11? Write 7.11 and square root of x button is given. 2.666, so 67 marks. Unit is marks. This is the simple way to find out the standard deviation. Always use the second types of formula, don't use first type because it will take more time. So whenever you are having ungrouped data, only one extra column. One column is x, that is observation, and one is extra x square. Okay? Again we are having the same type of sum. Second sum. The number of cars coming for service, second sum, in a 5 service stations of a company on a particular day are 7, 3, 11, 8, 9. Calculate standard deviation of number of cars coming at the service station. So I will write here. So second sum, number of cars is x and we require x square. 7, 3, 11, 8, 9. 7, 3, 11, 8, 9. So this thing is very easy if you are following me, okay? Don't do by yourself and don't think that why sir is not using shortcut method and why I am not using this and that thing. I am using the things which are easy for you, and I guarantee, I take the guarantee totally that what I am teaching will be easiest way. I don't require this shortcut method. Why you are required if you are having calculator? Others will tell you that values are very big, you will make mistake. But where will you make mistake? This thing is with you in the exam also. So how you will make mistake? Very fast we have solved the sum. Here also sum will be solved very fast. The thing you have to see is the speed. If you are not having speed, your 60% paper will only be completed. That I will guarantee. The students who are newly coming in standard 11th, they are not able to complete still 60 or 70% paper. So how will you attempt the paper? Think about it. Okay. Sigma x. 7, 3, 11, 8, 9. 38. Okay. First we will find mean. mean x bar is sigma x by n, 38 divided by 5. X bar will be 7.6 cars. Now 7 square is 49, 3 square is 9, 11 square is 121, 8 square is 64, 9 square is 81. 49, 9, 121, 64, 81 is 324. And a habit of checking 49, 9, 121, 64 and 81. Second is standard deviation. You have to write continuous. Okay, I am writing as per the spacing board. S is equals to in square root sigma x square by n minus x bar square. So 324 divided by 5 minus 7.6 whole square. So 324 divided by 5, 64.8 minus 7.6 into equals to 57.76. How to take the square into equals to? Write 7.6 into equals to. So 64.8 minus 57.76. Square root of 7.04. Press square root x button. So 2.653. So 2.65 cars. So see, very fast we have completed two sums. Now we are going for the third sum. So this is a raw data. Now for the third sum we are having discrete data. Sums are really very easy if you are believing me. So believe in yourself. Okay, don't follow the illustration in the book, because illustrations are help us whenever calculator was not allowed. In illustration, shortcut method is given for students where calculator is not allowed. Our government is allowing the calculator. Why to use that shortcut method? Okay. Let's read the next sum, third sum. Following frequency distribution represents the amount of deposits and the number of depositors in a bank. Find coefficient of standard deviation of the deposit. So for finding the coefficient, first we need standard deviation, then we can find the coefficient. Yeah. So third sum. Not number of deposits in rupees. Not in rupees, in 1,000 rupees. Deposits in 1,000 rupees. This is our x. First column is always x. Number of depositors is y. Sorry, not y. It's f. So the first column is x, second column is f. We need fx for mean and just we need fx square for standard deviation. And if you are not using this method, then 3 extra columns are to be prepared. No one will prepare. Okay? 5, 10, 15, 20, 25, 30, 30, 2, 7, 11, 15, 10, 4, 1. Okay. X total is not required. Sigma f will be our n. Sigma fx square. 2, 7, 11, 15, 10, 4, 1. N is 50. Now first we will find mean. So fx, 5 2s are 10, 10 7s are 70, 15 into 11, 165 I think. 165. 20 into 15, 300. Here 25 into 10, 250, 34s are 120, 35 ones are 35. So 10, 70, 165, 300, 250, 120 and 35, so 950. 10, 70, 165, 300, 250, 120 and 35. Yeah, so first mean. X bar is, now formula is sigma fx upon n, 950 upon 50, so it will be 19,000 rupees. 19,000 rupees, because the unit is 1000 rupees. Okay. Yeah. Now fx square. Now friends, how to find fx square actually? If you don't know, then you can write with pencil fx into x square. I will write fx into x. Fx into x means this column and this column, both these columns. So fx into x once more, so it will become fx square, fx into x. So 10 5s are 50, 17 into 10 is 700, 165 into 15 is 2475, 300 into 20, 6000, 250 into 25, 6250, 120 into 30, 3600, 35 into 35, 1225. Okay, so 10 into 5 50, 70 into 10 700, 165 into 15 is 2475, 3300 into 20 6000, 250 into 25 6250, 120 into 30 3600, 35 into 35 1225. So 50 700 2475, 6000 6250, 3600, 1225, it's 20,300. Have the habit of checking also. 6,625, 3600. Yeah. Second is standard deviation. Because we need coefficient, for that we require standard deviation. S is equals to in square root sigma fx square by n minus x bar whole square. Now instead of x square we have fx square. Okay, so fx square is 20,300. See, if you have habit of writing like this, you can easily find. Divide by n. See, here I am writing f is equals to n into 50 minus x bar square is 19 square. Everything is square. So 20,300 divided by 50, 406 minus 19 square is 361. So 45. So square root of 45 is 6.708, so 6.71 thousand rupees. Now, number 3, coefficient of standard deviation. Coefficient of standard deviation is equals to S upon x bar. 6.71 divided by 19. 6.71 divided by 19, 0.353, so 0.35, it will not have any unit. So friends, we have to find coefficient of standard deviation. For that we need mean and standard deviation. So discrete data is also over. Now for next question we are having continuous data. Fourth, the information of profits in lakh rupees of 50 firms in a last year is given below. Find standard deviation of profit of firms. Okay. So fourth sum, profit lakh rupees. This is our class. Number of firms, that is frequency f. Then we need an extra column, mid value x, now fx, then fx square. Only one extra column. Okay. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. 7, 6, 15, 12, 10. Don't require the total. Sigma f is equals to f. See, we are having so much value, so I am drawing each and every line. You don't have to draw. You have to draw the straight lines only. Why I am drawing like this, like a notebook? Because if I am writing up and down, then sometimes you are getting confused that this value is what. Okay, so I am drawing very detailed way. Okay. So x is also not required. Sigma fx is required, and sigma fx square is also. I am drawing these lines for only just a. Not confusing for everyone. Okay. Yes. 7, 6, 15, 12, 10. It's 50. Okay. Mid values. 0 plus 10 by 2 is 5. Then it will be 15. Then it will be gap is of 10. Then so 25. Then 35. 40. Now fx. 7 5s are 35. 15 6s are 90. 25 into 15, 375. 35 into 12, 420. 45 into 10, 450. Okay. 35, 90, 375, 420, 450. 1370. Let's check. Okay. First is mean. X bar is sigma fx upon n. 1370 upon n is 50. 1370 upon 50. It's 27.4. 27.4 lakh rupees. X bar. Yes. Okay. Now fx square. Fx square, how can we find? Fx multiply x. So fx multiply x, both are near only. 35 into 5, 175. 15 into 90, 1350. 375 into 25, 9375. 35 into 420, 14700. 45 into 450, 20250. Okay, 55 by 90, 25 to 375. 175, 1350, 9375, 14700, 2250. 45850. Okay. Number 2. So next is standard deviation. S is equals to, in square root, sigma fx square by n minus x bar square. Sigma fx square is 45850, n is 50, x bar is 27.4 whole square. 45850 divided by 50. 917 minus 27.4 whole square, so into equals to 750.76 in square root. So 917 minus 750.76, so 166.24, take it square root, 12.89 lakh rupees. I think we don't have to find coefficient, so this is enough. So friends, now you only decide that in the illustration that D method is given and we will assume our mean and we will do that, or we will do the method which I am teaching. Very simple to calculate. What is there? You are having calculator, you are free to calculate anything. But still some people don't understand. They want the digest method. Let them do the digest method later. I will also decide how much marks I have to give. Because the thing, if the road is straight and you are going from somewhere else, so it's not proper. Okay, so the thing which I am teaching, that should be followed compulsorily, let you know or don't know. Yeah, good. Yes, now last sum. So last sum again, standard deviation topic is today only completed. Okay, so now tomorrow last topic will be left, so chapter will be completed. Fifth sum. Find the standard deviation of age of person from the following distribution of 125 persons living in a society. Also find coefficient of standard deviation. So standard deviation and coefficient of standard deviation both are required. Again, class data is there. So last sum of this exercise, fifth sum. First column, age in years, it is class. Number of persons, it is frequency f. We need mid value x, then we need fx, then we need fx square. 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. 15, 15, 23, 22, 25, 10, 5, 10. Sigma f is equals to n is equals to, we are not required, sigma fx and sigma fx. Yeah. 15, 15, 23, 22, 25, 10, 5, 10, 125. Okay, mid values. 5. Again 10, 10 difference is only there, 15, 25, 35, 45, 55, 65, 75. Now fx, 15 5s are 75, 15 into 15 to 25, 23 into 25, 575, 22 into 35, 770, 25 into 45, 1125, 10 into 55, 550, 5 into 65, 325, and 75 into 10 is 750. So if you want, you can check again if you are having doubt in some. 75, 225, 575, 770, 1125, 550, 325, 750, 4395. So first we can find mean. So number 1, mean. Okay, x bar is equals to sigma fx upon n. So 4395 upon 125. 35.16 years. 35.16 years. Second, we can do that. Okay, fx into x. 75 into 5, 375. 225 into 15, 3375. 25 into 575, 14375. 35 into 770, 26950. 45 into 1125, 5625. 55 into 550, 30,250. 65 into 325, 21,125. 75 into 750, 56250. So if you want, we can check again. 25 into 575, 14375, 35 into 770, 26950, 45 into 1125. We can check if we need. Okay, 55 into 550, 65 into 325, 75. Yeah, 375, 3375, 14375, 26950, 50, 625, 30, 250, 21125, 56, 250. Okay, 2,03,325. 2,03,325. So standard deviation S is equals to, in the square root, sigma fx square by n minus x bar square. 2,03,325 divided by 125 minus 35.16 whole square in the square root. 203,325 divided by 125, 1626.6 minus 35.16 whole square, 1236.225, so 23. Check very carefully. Okay, now 1626.6 minus 1236.23, so it is 390.37 square root 19.75. 19.76 it is actually 19.757, so 19.76 years. This is our S. I was checking coefficient. Yes, coefficient is required. Coefficient of standard deviation. Coefficient of standard deviation is equals to S upon x1. 19.76 divided by 35.16. 19.76 divided by 35.16. 0.562, so 0.56. So yesterday's lecture we have completed quartile deviation. This lecture we have completed. Today's lecture totally standard deviation. Now only single topic is left, coefficient of variation. Now the coefficient of variation is completed, so our chapter is completed. Again, one more thing. See, I am not taking the last exercise of every chapter. Reason is simple, that we will take at the time of revision. Okay, so first we are completing our course, so I think this is the last chapter. At every time this is the last chapter, after that all the chapters are in next term. So till this first term 4 chapters are there, and we have completed only one exercise is left. So now statistics is completed, but so much thing is left in accounts. From chapter number 5 to chapter number 11 we have to complete all the chapters. So much chapters are left. So after completing the last exercise of this, next exercise of this chapter, we are continuously going for account, and every day we will take accountancy only. Okay, so now till that time complete this thing, and after completing that accounts we are doing our revision. So that's all for today. Thank you so much.